Hey everybody, this is Snowy88, and as you can see, this is a nice little picture of the Saturn moon Titan, and what you are seeing here is a reflection of its lakes. And the big question is now is, can you actually swim in these Titan's lakes? I have thought about it, and my conclusion is yes, you can. I tell you why. Because if we take the density of water and compare it to the density of liquid methane, we come to the conclusion that methane is only half the density of water. So you might think, well, if it's only half the density of water, then I will sink straight to the bottom, right? No, you do not. Because this moon, Titan, only has 1/7 the gravity of Earth. Also, when you are in the liquid, your weight is reduced by about half of the original weight itself. So let's take, for example, a person who weighs 70 kilograms on Earth. So if he went to Titan, he would only weigh 10 kilograms there. That's 7 times lighter than on Earth. If this guy takes a plunge into these lakes, he would actually float in it. It's also noteworthy to say that the atmosphere of Titan is 1.5 times thicker than the Earth, and because of the cold, because it's minus 180 degrees out there, the effective atmospheric pressure is even higher at 4.5 times Earth. So it's like if you are, well, the atmosphere is it's hard to describe because we are used to air on one side and water on the other side, and think of it something in between. So what's between air and water about density? So if we take Mr. Jack, he is on one of these islands, and he is standing here, and he's watching probably to the north, I guess. Yes, this is near the North Pole. This is I guess this is Lagera Mare, if I am right, but it does not matter. And he is going into this sea of methane, and the methane also contains a little bit of ethane and even propane, but that does not really affect its properties. So I think he does not need much effort to stay afloat, because there was this guy, and I forgot his name. He is a scientist, and he said once that, well, if you put on some wings on your arms, or even flap with your arms, you could fly on Titan. And well, it's a fascinating thought, you can fly on this planet and take a flight over this terrain just by flapping your arms with maybe a little bit tiny wings on your arms. So imagine you are swimming here. Although this stuff is thinner than water, it's easy for you to grab the dense air, which is 4.5 times thicker than Earth, than here on Earth. although the water itself is thicker, the air on Titan is so much thicker, and you are weighing only 10 kilograms effectively, that it would be peanuts. It would be peanuts to swim here. The only downside is that it is very, very, very chilly. This stuff is minus 180 degrees Celsius. So if you are going for a swim, and maybe in the future we have to come up with some kind of isolation suit that isolates you completely 100% from your environment. If it does not, if your suit does give up the slightest amount of heat, then this liquid stuff, which is at the edge of its boiling point, will literally evaporate beneath you. So if you throw something warm in here, it will sink straight to the bottom. Finally, it will freeze solid because there is a lot of methane here, but it will sink to the bottom immediately because it's so warm. So if you take a plunge, don't forget to take your good isolation suit with you. And the nicest thing about this world, and I have said it before in other videos, is that not only swimming is possible in liquid methane, but this moon by itself is also the best candidate for colonizing. Most people think that Mars is the best planet for colonizing, but I am a firm believer of the fact that this world is a better place to colonize. Okay, granted, it is farther away. It will take more years to get there, but the price is bigger. And okay, it may be a bit colder, but don't forget, Mars can be cold too. Mars can get temperatures of minus 60, minus 70, or even minus 80 degrees. It's also something to take in account. If you go to Mars, you need isolation as well. So if it is minus 80 or minus 180, that doesn't matter. But the fact is, Titan, it has a very thick atmosphere which prevents cosmic radiation and deadly radiation from the sun and deadly cosmic radiation from the universe to penetrate to the surface. And the moon also lies within the magnetic field of Saturn, so it gets protection from that as well. Another positive aspect of this moon is its atmospheric pressure, which is under normal circumstances 1.5 times that of Earth. So it's easy to adapt. You maybe have to get used to it a little bit, but 1.5 bar, well, that's something we can handle. We don't have to build pressure domes like on Mars. Mars has barely any atmosphere, and if we are colonizing Mars, then we are bombarded with cosmic radiation, with solar radiation, solar flares, and all that stuff. Mars is just only convenient because it's close by. And I know all those guys at NASA, and ESA, JAXA, and maybe even North Korea, whoever wants to go there, are all looking at their wallet and say, well, Mars is closest by, that's the cheapest way to go, so let's go there. But they don't look at the bigger picture in general. Besides, this moon, it's not a dry moon. It's offering a lot of stuff. It's offering a lot of materials to work with. And it has a climate. It has real rivers. You can see those rivers here. These rivers, I suppose it rains now and then on Titan. Liquid methane is raining down, and all that fluid is collecting to one point, and then finally, like on Earth, it's flowing straight toward the lowest point in the neighborhood. Well, that's this location. So, and fascinating aspect of this picture, there are even islands here and here, and so on. So, and what you see here there are even changes within the lakes. This picture tells something about this one was taken a few years ago, and this one was taken somewhat later, and this feature appeared suddenly out of the blue. This feature is not visible here, so that means that this is an active sea, and what this is probably, I think, season related. It could be an iceberg or something like that, because, well, it's summertime now on Titan, if I'm correct. Yes, it's summertime now there. So, for all we know, this lump has been sitting on the bottom, and because of the increased temperatures, maybe it has come up and it has been saturated again and is sinking down again, and it's gone again. So, but that's only one of the aspects of Titan. And another fact that makes Titan more interesting is the aspect of the probability of finding life. It is not impossible that there is life in these lakes. It is said that creatures can exist who do not use oxygen to breathe, but only H2. And, well, I cannot define how such a creature would live there, or what they eat, and how they would live at minus 180 degrees. But, you know, the universe is a very big place, and if I look at Earth and I see all the diversity on Earth, I would not be looking strange for some reason if there is something here as well. There are so many diverse creatures here on this planet that it's beyond imagination. It's, well, to put it mildly, I like science, but well, I'm not a religious figure, but well, sometimes I think, well, has this come all from evolution, all from nothing, all from the combination of some lightning bolts and a mix of ammonia and nitrogen and some other stuff 4 billion years ago? Well, I don't know. I don't want to talk about religion in this matter, so, but, well, imagine how this even must look like. We all have seen on chemistry on school what liquid nitrogen looks like. Well, basically this stuff looks like the same, and the point is, liquid methane is a very bad solvent, and that means that if you put something in here like biscuit, cookie, it won't get wet. I think if you jump in it, you won't get wet. You don't need a towel, so you can go. Let's see, what is a nice place. Well, let's go here. Let's go to the east side of this sea, It's a nice sunny day, it's okay, it's a bit chilly out there, but you don't need your towel anyway, so you just jump in, you get out, and you are still dry. This stuff does not stick on you, and it is probably crystal clear, because it's a bad solvent. Nothing will really solve into methane. If you take water on the other hand, water is a very good solvent. I mean, go outside, pick your nearest lake or canal or sea or whatever, and how far can you look to the bottom? I don't think you can look 1 meter down and you don't see anything anymore, because the water mixes with the sand, it mixes with other stuff in the sand, and in the ocean it mixes with salt and well, God knows what other stuff there is. So this stuff must be very clear. It must be. I'm not sure how this would look like. Nobody really knows, but it's always fascinating to speculate about this. There is also the debate about why Cassini did not see any waves on this moon in these seas, because if there were waves, you would see this as reflections on these radar images. As you know, these pictures are not really pictures, but computer generated images made from radar signals which were transmitted to the surface and came back to the spacecraft, and the amount of time the radar signals took to get back gave an impression of the elevation of this environment, and also the how do you say it? Well, in any case, since I'm not an English native speaker, I sometimes have trouble finding my words. So I could not find the words I was searching for. My excuse for that. So, but where were we? This stuff is probably crystal clear, and I think you can look down very deep into it. I don't think you can see all the way to the bottom, but oh yeah, we were talking about the waves. Why don't we see waves? Well, I have a very good explanation for why we don't see waves. Because you would expect, if the atmosphere is 4.5 times thicker with that temperature than on Earth, that a little breeze would cause some wave action. Well, my thought is, and that is just my thought, I cannot prove it because I'm not a scientist, I'm just a theorist, a hobbyist, but I think the methane, that it is not able to form waves at all. So the wind will try to make a wave. The methane is so thin that it collapses on itself. You can compare this with trying to build a sand castle with bone dry sand. That won't work. You can pile up the sand, but you cannot build a sand castle from it. Why not? Because it misses something. It misses it is too dry. It misses an element. In this case, water. Water makes sand more stickier. So I think that is the reason why there are no waves on Titan, because simply put, methane in its liquid form is too thin to form waves. So that brings us to the last point of this video, and that is about the viscosity of this stuff. Some people have said it must be like a tar, like a very, very gluey stuff. I don't think so. I think it's very, very thin stuff, very, very fluent. It will go through places where water even can't go, because it has only half the density of water, so it could fit through places where water cannot go through. So even if you want to swim in this, make sure you've got a suit that is not only holding water out, but liquid methane as well. So my end conclusion to swimming in the methane lakes, well, I say yes, it's possible. And I do not only say it's possible, I say it is easy, because you are only weighing 10 kilograms if you are 70 kilograms on Earth. The moon has only 1/7 the gravity, but it has 4.5 times the atmospheric pressure. So if you are swimming in that liquid and you swing with your arms through the air, you can grip more air to pull yourself forward and upward than here on Earth, because the air here on Earth is 4.5 times thinner. So that's my case, and I hope NASA, ESA, or any other space agency will send another mission to this moon very soon. I cannot wait. If we only send a probe there, which will land on the shore of one of these lakes, then takes a high definition photo of it, I would be happy. Then I would just be happy, just to see how it looks like. You know why? Because this is the only photograph Huygens made of Titan's surface. They spent billions of dollars on a spacecraft, and what kind of camera put they on? I just made it bigger. They put a camera on it with such a small window, and alright, they made 300 of these pictures and they sent the data back to the spacecraft. Wouldn't it have been more suitable to use the bandwidth to make just one big picture with higher resolution and more depth of field of depth? And because what do we see here? I mean, this could be on Earth for all we know, just a pebble field in some desert. This does not say anything. They can enhance the stuff like this, but this could just be on Earth. I'm not really convinced about this picture. Sure, these are pebbles, and this is probably, here is probably some liquid flowing, but I'm not too convinced. I was very disappointed in 2005 when the first pictures came in, and let's go back. Whoa, that is small. Let's make it bigger. Titan surface. I mean, what to make of this? What is this? Is this an image or is this a drawing, or what is it? I can hardly make anything of this. Can you? I cannot. It's alien to me. It just looks like a painting. And there was another. let's take a look at this one. View image. Let's make it bigger. Well, what can we make of this? I mean, this is so unclear. Well, alright, we can see some lines, and this appears to be a coast, but it was said that this was just a dried up sand bed, this dark area, and this higher area is well, higher area. But look at this sky. I mean, that can't be right, unless they overlighted the camera, that because probably Titan is a very dark place if it already has a dense atmosphere, and at its distance from the sun, it's probably a dark place. I mean, even at noon it will probably be a twilight zone there. So there are some mission proposals, and none of them are really taken serious. I found this one also a nice one. It would take not much energy to fly a plane on Titan, since the atmospheric pressure is so thick, and the atmosphere is thick, and you need a little propeller or small wings. It can all be made of very cheap and very light materials, and you can just attach a very small propeller behind it, and it can go around Titan several times and make detailed images of its surface. So well, that's my Titan story for so far, and the original question of course was, can we swim on the Titan lakes? And yes, we can. I mean, you probably don't even have to swim. I think you can float in this stuff. Just move a bit and you will float, just like in the Dead Sea in Israel and in Jordan. Dead Sea lies in Jordan? Dead Sea. Look, Dead Sea. Where is that? This is nice. Dead Sea map. Where are you? Ooh. Okay. Dead Sea. Yes, it's between Israel and Jordan and the West Bank. So the Dead Sea is probably some kind of analog to the Titan Lake, because well, it contains so much salt you can float in it, and I think you can float in this stuff as well. So thank you for watching. Leave your comments in the comment section below what you think of it. If I missed something about the properties of the named elements, like the liquid methane, such as well, what about the atmospheric pressure, how cold is it exactly, wind speeds, well, you name it. You tell me, what do you think? Tell me please if you would like to stand here and walk in here, not knowing what lies beneath in here. For all we know, there are megalodons in here. Okay, swimming in Titan Lake becoming eaten in Titan Lakes. And okay, we are finishing this video. Thank you for watching, and see you next time. Bye bye.